notation. It's kind of like a Sesame Street song or something. Maybe not anymore. So you're going to look at this big boy math. You ever seen that symbol before?
Yeah.
That means summation. That means summation. You'll see it in pre-calc and calc, and this is the beginning of it. And what it basically, it means summation, and you might see it called sigma. Might be called sigma. What it does is it usually gives you like a starting value. Let's say the starting number in your series or sequence is 6. Let's say that's the first term. It'll give you the first term on the bottom. And let's say it goes up to 28. It gives you the top term on the top. So let's say your sequence goes from 6 to 28. Maybe it goes up by 2s. So 6, 8, 10, 12, 14, 16, up to 28. That's what this means. This is the beginning number, and that's the ending number in the sequence. Okay? And then it'll give you a function. Let's say the function is for I. I is not imaginary. I don't know why they use I as the variable, but they do. Okay? It doesn't mean imaginary here. This is just the function. So let's write this here. That's a function. This is the beginning. Yeah, it's like the function fish. The beginning number or the beginning input. Let's say beginning input. And the ending input. And it'll make more sense when we get to a problem like this. Okay? So what you're doing is you're adding the output for every input that you're putting into it. You're going to add them all up. It's summing it up, summation. And we'll get to that in a second. All right, so we're just going to jump right down here. Tell whether the sequence is arithmetic. That means is the difference between each term. These are called terms. You need to know that. This is kind of like showing these numbers here. Those are called terms. Is the difference constant from one term to the next? What's it going up by or down by?
6.
Yeah, we add 6 each time. So yes, it is arithmetic. The difference is the same from one to the next. How about here? What's happening here? Add 4, add 4, uh-oh. Add 6, nope, it's not arithmetic. That's all you're deciding is whether the difference is constant, okay? So, here's the first thing that's on your green sheet. You'll notice it's right here. The rule for this arithmetic sequence. Basically, the nth term, like for example here, this is the first term. That's the first term, the second term, the third term, the nth term could be way up here. That's what that means. The nth term of an arithmetic sequence with the first term A1 and the common difference is D. So here, let me explain what this means. 7 is A1 here. That's the first term. What is D up here? What's the difference? 6. So what it's saying here is the nth term, that means I could find any term here, the value of any term, the nth term of an arithmetic sequence with the first term A1 and the common difference D is given by this. You can use this formula. That's the first term. That's maybe the number you're looking for. That's the difference. So you're going to be working with this to find out these different parts of these sequences. Okay? So first of all, let's just try it a little bit. Here it says write a rule for the nth term of the sequence. That's the first thing I have to do. We're going to be using this. Then find A of 20. That's the second thing I'm going to do. So I got two things, two separate things. First I have to write the rule, then the sequence. All right. So write a rule for the nth term. So in this, I need to know A1. What is my A1? It's the first term in my sequence. That's my A1. And I need to know the D. What's D? What's it changing by each time? -3. Once I have those two things, then I can plug them in. So I'm going to say, okay, A of n. Any term in there can be found by the first term plus whatever number it is you're looking for, minus 1, times your d. This is coming up with just the rule. We're just finding the rule, the general rule for this sequence. So I can simplify this. Let me put this in parentheses, it might be clearer. We're going to distribute that. In order to write the rule, we got to make it prettier. So A of n equals negative 3n plus 3. Distributing. And I'm going to simplify here by combining the like terms, and it would be negative 4 plus negative 3 of n. Okay, so this is the rule. This is part 1. I've come up with the rule. Now it says find A of 20. 20 is what letter in this equation? N. 20 is n. N equals 20. So I'm going to plug it into my equation. So the 20th term is going to have a value of A of 20 equals negative 64. So if I went up 20 terms in here, it would be negative 64 in that sequence. Does that make sense? That's what you use it for, okay? All right, you try this one then the same way. You try this one the same way that we just did this. Do this one. First you have to find D. You need to know D. And obviously they gave you A of 1. They gave you the first term. Find D and then write the function and then find A of 20. Guys, for clarity, I wrote this up here just in case you look back at this and you can't remember what it means. N is the nth term. It's just giving you the nth term. A of 1 is the first term in the sequence. D is the difference between each term. Okay? So if you want to write that down just for clarity, the difference between each term. You could even write it right on this green sheet. You may not need it, but, you know, maybe, if that helps you. Okay. You know it gets better.
It always gets better.
I'm going to need it. So A of n equals A of 1 plus n minus 1 times the difference. Okay. So here, what they're doing is they're giving you two of the values of two different terms here. Two terms of an arithmetic sequence are A of 10 is 148, the 10th term is 148, and the 44th term is 556. Find a rule for the nth term. So we're going to kind of work, what we need to do for sure for the rule is we need A of 1 and we need D. We don't have either of those right now, but we can find them. We have the math capability to find them. So I'm going to start with what I know. A of 10 equals 148. I know that the 10 is an n, correct? That's the 10th term. That's one of my terms. That's n. I may be able to use that. I also know at that spot, 148 is A of n. That's the output, basically. So I'm going to write what I know into this function. So this is the first thing I'm going to do is I'm going to write what I know into this function. A of n is 148, equals. I don't know A of 1 at this point. I do know that n is 10 minus 1 times d. So this is stuff that I know. I'm going to simplify that and make it a little prettier. If I distribute that d and take care of business, I end up with, this is 9 in here, isn't it? 10 minus 1 is 9. So I'm going to write it as 148 equals A of 1 plus 9d. Okay. I have another piece of information that I can do the same thing with. So let's do that. I have this right here. I have A 44th term is 556. So I'm going to do the same thing with that. The output is 556 for the 44th term. I don't know the starting term. I do know n at that point is 44. I don't know d still. So this is actually 43 inside here. So I'm going to rewrite it over here. 556 equals a of 1 plus 43d. Oh, this is back to some chapter from last semester. Do you remember elimination? We can eliminate here. What can we eliminate? A of 1, and then we get d. Isn't that nifty? Totally. So I'm going to eliminate down by subtracting. I'm going to eliminate down by subtracting so I can get rid of a of 1. So I'm going to subtract all of this. Okay? So 148 minus 556 is going to be negative 408. Yeah. Doesn't matter. It won't be too bad, but yes, you could. Absolutely. A of 1, take away a of 1, they go away. And then 9d, take away 43d, gives me negative 34d. Oh, and it's just a simple algebra to get d. D equals 12. So I have one of the things that I need. Can I easily get a of 1 now? I can just stick it into one of these. Doesn't matter. Stick it into the first one. Okay? So I'm going to take d and plug it into my first equation. 148 equals a of 1 plus 9 times 12. So I stuck d into my first equation. Right here. And then I find that a sub 1, my first term, would be 40. Oh! Now I have what I need to write the function. I need a of 1 and d, and I have it. So now I can just write the rule. So I'm going to go back up here. A of n equals my first term, which is 40, plus n minus 1 times my d. And I'm done. That's exactly what I had to do. No? You can just leave it like that. Now I can stick any number in. Like I want to know the 22nd term, I can stick in n and find out the value of the 22nd term. If I want to know the 8th term, I can stick in 8 for n and know what the 8th term is. Make sense? Okay. All right, here we go. So now, let's say we have this. All the way up to, I don't know, 26. And I have some function that I'm going to plug each of those terms into, find out what their value is, and add them all together. I want a sum of their values. That's a pain in the butt to do by hand. You can do it using this formula. The sum of the first n terms of an arithmetic series is denoted by this. S of n equals n times your first term plus however many you want to include in this sum divided by 2. Okay? Now, this is where that summation came in. This right here is what I was talking about on the front page. This is not I as you know it. It's just a variable. It's not an imaginary number. Okay? It's just a function with the variable I. So, the first input is 1. And we're going to go up to the 28th term. So that's the last input, or the last term. And this is the function right here. So, what I need for here is, I need a of 1. The output when I stick in 1 to this function, I need that. The a of 1 is the value of the first term when I stick 1 in. And I need a of 28, because I need the value of the first term and the value of the last term in order to use this. So I need a of 1, and I can find that out. All I have to do is plug in 1 for I into my function. I just have to plug in 1. So it's not too bad. Negative 2 plus 4 times 1 That's the first number I'm sticking into that function, is the number 1. So the first number in my sequence would be 2. A of 1 would be 2. That's A of 1. Then I need A of n, which is going to be 28. I need A of 28. So that's telling me I'm going to go up to 28 inputs. So I'm going to stick in -2 plus 4 times 28 equals 110. That's my A of n. That's the last term in my sequence, the last value of the last term. Now I have A of 1 and A of n. I can stick it in here and find the sum of all these values. If I put 1 in, I found out I get 2 from this function. If I put 2 in, I'm going to get some value. If I put 3 in, I'm going to get some value. If I put 28 in, I'm going to get 110. I want to add all of those outputs up. I want a sum. That's what this does for me. Okay? So I'm going to use that to find out what that sum is. S of n equals the total number of terms, which was 28, times my A of 1, which is 2, plus my 110, which was A of 28, divided by 2. And when I do that math, S of n, I get 1568. So that gives me the sum of all the terms in that series or sequence. Okay. Oh, there's no picture here, but we get to do it anyway. Yeah, let's just think about it.
No.
No, we don't have to do it. Never mind.
We somehow can't at the bottom.
We don't have to do it. Yeah, this is the homework that I have so far. Yep, that's it.
Make a spreadsheet right now.
Guys,